Hey students, in this video we're going to go through section 7.4 about three-dimensional figures. Today's learning target is I can describe and draw three-dimensional figures. We have some vocab terms up here first. Our first term is solid. A solid is a 3D figure that encloses a space. So think about a box that has a lid on it. If we put something inside that box, it wouldn't fall out. It's fully enclosed. It is a solid. If we removed the lid, however, it would not be a solid anymore. Something inside the box could fall out. So a solid is fully enclosed. A polyhedron is a solid whose faces are polygons. That means our solid is only made up of multi-sided figures like squares, rectangles, triangles, trapezoids. We are not going to have anything that has circles in it or on it, so no cylinders, cones, or spheres. The three terms that we're going to talk about in relationship to these polyhedrons, these solids, are face, edge, and vertex. So let's start with face. A face is a flat surface of a polyhedron. If we look at this example here, this top rectangle, I'm going to color it in pink. That is an example of a face. It is a flat surface of my polyhedron. I'm actually going to also put pink around the word face and draw a pink arrow to that to help me realize that is a face, a flat surface of my polyhedron. My next term is an edge. An edge is a line segment where two faces intersect. So this top rectangle is a face, this front rectangle is a face. The line where they intersect, that is called an edge. Think about like the edge of a cliff, right? Where the top and side of the cliff meet, that's called the edge. So I'm actually going to draw purple on all the edges of this to help me see all the edges, all the line segments, including the dotted ones. The only reason they're dotted is to help us see that it's a 3D figure. And I'm going to draw an arrow to two of those to help me see those two examples of an edge. And finally, a vertex is a point where three or more edges intersect. So I have an edge here, here, and where they intersect, that little point, that is called a vertex. Multiple of them are called vertices. So I'm going to put little green dot on all of my vertices, all my little points to help me see all the vertices. And then I'm going to draw an arrow to a couple of them. So face is a flat surface. Think about like the face of the earth, that's a surface. An edge is like the edge of a cliff, and a vertex is a little point or a little corner. So now we're going to practice counting the number of faces, edges, and vertices on a solid, specifically this one here. So I'm going to write F, E, and V, faces, edges, and vertices, and we're going to count each. First, we're going to count the faces. Remember, the faces are the flat surfaces. So I see one in the front. There must also be one in the back because this is fully enclosed. So front and back makes two. I then have the top. There must be a bottom as well if this is fully enclosed. So top and bottom. Now we're at four. And finally, I have this on the side and this on the side. That makes six in all. Top and bottom, front and back, side and side, six in all. Next, I'm going to count the edges. Remember, the edges are the line segments where the faces intersect. So I'm going to use my purple pen again, and I'm going to start tracing all of the line segments that make up this figure. If I go around the top first, there are 1, 2, 3, 4 around the top, 4 edges around the top. Then if I go to the bottom, there are 1, 2, 3, 4 along the bottom as well. That puts us at 8 so far. 4 and 4 make 8. Don't forget these ones going up and down. 5. Sorry, I was at 8, so that would be 9, 10, 11, 12, 12 in all. There are 12 edges on this solid. 4 around the top, 4 around the bottom, 4 going up and down. And finally, the vertices. Remember, the vertices are the little points, little corners. There's actually dots on these already for us. I'm going to go over it in green just to show you. But the vertices, the little points or corners, we have 4 around the top. 1, 2, 3, 4 around the top. 5, 6, 7, 8 around the bottom. 8 vertices in all. So faces, flat surfaces. Edges are like the edge of a cliff, line segments. And vertices, a vertex is a little point, a little corner. Now we're going to move on to the next couple vocab terms, prism and pyramid. A prism is a polyhedron with two parallel identical bases. The lateral faces are parallelograms. So that means on a prism, there should be two bases. I should be able to hold the prism with both of my hands like this. And my hands should be parallel. Those two bases should be parallel. However I'm holding it should make my hand seem parallel. Those two bases should also be identical. So I should have two bases that are the exact same shape that are parallel to each other. The faces that then connect those are called lateral faces. Those are going to be parallelograms, normally a rectangle. So on this example here, I have a base there and a base there. They are parallel, right? If I held this between my hands with one hand on each triangle, my hands would be parallel. They're the same exact triangle. So they're identical. And the lateral faces, the ones connecting them, are rectangles. We have a rectangle here on this side, one on the other side, and one on the bottom. But the bottom line is a prism has two bases, two identical parallel bases. A pyramid has only one base. So a prism has two, a pyramid just has one, like this. It looks like the pyramids in Egypt. The lateral faces, the faces that are connected to the base, are going to be triangles. So prism has two bases that are parallel and identical. The faces connecting them are rectangles. For a pyramid, we have just one base, and then the faces connected to each other are going to be triangles. Prism has two bases, a pyramid has one. Now you might wonder how we decided to name these triangular prism or rectangular pyramid. Well, the name of this triangular and rectangular, that comes from the shape of the base. Because this has rectangular bases right there and right there, that's why it's called a triangular prism. Because this one has a rectangular base, that's why it's called a rectangular pyramid. So the shape of the base names the figure. Whatever shape the base or bases are, that is how we name that particular figure. So if it has a triangle base, we call it triangular. If it has rectangle bases, we call it rectangular. If it had a pentagon base or bases, we would call it pentagonal. So we're going to practice drawing these things. First, we're going to draw a triangular pyramid. Well, it's a pyramid. Pyramids have one base, so I know that. It's a triangular pyramid. That means that the base is going to be a triangle. So let's start by drawing that one triangle base. There's my one triangle base. There's not another base across from it. There's just the one. So up top, it's just going to be a single point. My pyramid all meets at the top at a single point. So I have my one triangular base. It's going to meet at a single point. All I have to do is now connect them. 1, 2, 3. Now this doesn't look the best ever, and that's because we don't have any dashed or dotted lines like these had. So we're going to go ahead and erase these lines that would be kind of on the back of our pyramid. I'm going to lightly erase them and redraw them, but dashed or dotted to help give it a little bit more of a 3D look. So here is our triangular pyramid. Again, it's a pyramid. It has one base. It's triangular, so that means the base is a triangle. Next, we're going to draw a rectangular prism. It's a prism, which means it has two bases, and it's called a rectangular prism. That means those two bases are going to be rectangles. So we know that's what we can start with. So I'm going to start with one rectangular base, and then I'm going to draw a second rectangular base. And I want them to be about the same size because they're supposed to be identical. Okay, that's pretty close. So those are my two bases because it's a prism. They're rectangulars because it's called rectangles because it's called rectangular. Now all I have to do is connect them. Top left to top left, top right to top right, bottom right to bottom right, bottom left to bottom left. And again, just like last time, those lines that would be in the back or on the bottom, we're going to go ahead and lightly erase them and redraw them in to be dashed or dotted so it has a bit more of a 3D effect. There we go. That is our rectangular prism. So the main thing I want us to remember about this is that a prism has two bases, a pyramid has one, and its name, triangular, rectangular, whatever it may be, comes from the shape of the base or the shape of the bases. Our final example, we're going to find the faces, edges, and vertices of this diamond, and then we're going to draw the front, side, and top views of it. So let's start with identifying, counting faces, edges, and vertices. So if I count the faces, I'm going to start at the very top. I have one square at the very top. I then have a trapezoid coming off each side of that square, so that makes 2, 3, 4, and 5. I'm at 5 so far. And then I have a triangle coming off of each of those trapezoids. So I was at 5, now I have 6, 7, 8, and 9. 9 faces in all. 4 triangles, 4 trapezoids, and 1 square. Next, I'm going to count the edges. So in my purple pen, I'm going to trace over all the edges, the line segments in this one. I'm going to start at the top. There are 1, 2, 3, 4 around the top square. If I move down to kind of this next level, I have 5, 6, 7, 8. And now I need to go in and count the ones going up and down. 9, 10, 11 in the back, and 12. And then these last ones that go down to the bottom. 13, 14, 15 in the back, 16. There are 16 edges in all. 16 edges in this figure. And then we have vertices. Remember, vertices are the little points, the corners. So I'm going to use my green pen to color a dot over each of those. So I have 1, 2, 3, 4 around the top. And if I go down to this kind of next level, I have 5, 6, 7 in the back, and 8. And then don't forget the one at the very bottom, 9. There are 9 vertices in all. So we counted faces, edges, and vertices. Now let's go ahead and draw the front, side, and top views of this particular solid. And I actually have a little model here that we can look at. So we're going to look at it from the front first. This is what it would look like from the front. So I see a triangle below with a trapezoid on top. That's what it looks like if we look at it just from the front. So that's what we're going to draw. We have a triangle on the bottom with a little trapezoid on the top. So that was the front view. Now I'm going to go ahead and turn it to the side. Well, you might notice the side looks the exact same as the front. So I'm going to draw the exact same picture. This looks the same from the front and the side. And then lastly, I need to look at this from the top. What would it look like from the top? Well, if I look at it from the top, I see a square in the middle with 4 trapezoids around the outside. Or another way to describe it would be a smaller square inside a larger square, and the corners are all connected. Smaller square, larger square, and then the corners are all connected. That's what it looks like from the top. So here we're just drawing kind of a one-dimensional view based on which way we look at our figure.